Okay, hello students, and welcome to today's Friday Happy Math Hour. Today, I'm going to go over the topics for exam one review. Okay, there's going to be, I think, like 21 questions. Okay, and for example, some of these, put in my exams. Okay, but I got 21 questions. That way, maybe some of your instructors will cover other questions that I don't cover here. Okay, but let's start. Number one. Number one is very important, guys, because it's filling out the unit circle. Okay, this is what I give to my students at the beginning of the exam for them to fill it out because they have to know the unit circle. Okay, so I have a plan how to know the unit circle, but it's going to be like in two parts. Okay, this is your unit circle, so you have to know three main components, which is a radiant, which is, pi over 6 is radiant, and the degrees is also another component, and the point. So it's radiant, degrees, and the point. Okay, now here it is, right? So for pi over 6, that's radiant, 30 degrees is degrees, and the point is the square root of 3 over 2, 1/2. There's only like 3 points that you really have to know, okay? Everything with the 6 on the bottom, right? If you notice, this is your point, the square root of 3 over 2, 1/2. You see the pi over 6, same point. The 5 pi over 6, also same point. The 7 pi over 6, same point. And 11 pi over 6, same point. But the difference is that the quadrant tells you if it's going to be positive or negative, the x and the y. Quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. Now going back to the radians, you see, for example, everything with a 4 in the denominator, right? This is your point. You see, there's a pi over 4, that's the same point. 3 pi over 4, same point, but it's going to be negative, positive. 5 pi over 4, also same point, right? The x and the y are the same, and they're both going to be negative. And 7 pi over 4 is positive, negative. And also, in the same fashion, the pi over 3 is also the same point, right? But again, depends on the quadrant, if it's positive or negative. You see here's a pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. If you notice, all these points in quadrant 1, they repeat themselves, but in quadrant 2, quadrant 3, quadrant 4, and again, the signs determine, the quadrant determines the signs. So let's continue with how to construct a circle in two parts, right? So this is part 1. In part 1, right, first I'm going to do radians, then the degrees, and then the point. For part 1, I'm going to cut the circle in, let's see, in 12 equal parts. In 8 equal parts. You see, each quadrant, I'm going to cut it in half. I'm sorry about that. So now we're going to count by pi over 4. This will give us pi over 4, 2 pi over 4, 3 pi over 4, right? And then 4, then 5, 6, 7, and 8. 8 pi over 4. Now these are the ones that can be reduced. The 2 pi over 4 will be pi over 2. The 4 pi over 4 will give us pi. The 6 pi over 4 will give us 3 pi over 2. And 8 pi over 4 will give us 2 pi. That's what you got to know for radians. Now for the degrees, we're going to count, right? The degrees is next. We're going to count by 45s, right? Because if it's 8 equal parts all the way around, another way around is 360. 360 divided by 8 will give us 45. So I'm going to count by 45. So 45 degrees. And then you keep adding 45. So 45 and 45 is 90. 90 and 45 is 135. 135 and 45 will be 180. 180 and 45 will give us 225. 225 plus 45 will give us 270. 270 plus 45 will give us 315. And finally, 315 plus 45 will give us a 360. That covers the radiant and the degrees. Now comes the points. Okay? If you notice, right, this is like the coordinate plane, right? This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. These will always be the same. The pi over 2, the pi, the 3 pi over 2, and the 2 pi. They will always be the same. Okay, now, then comes the x and the y. If you notice, this is the x, right? The distance for the x, and this is my y. If you notice, these are the same, which means both points, both x and y have to be the same. And recall from the previous slide that I told you that everything with a 4 on the bottom is going to be square root of 2 over 2, square root of 2 over 2. So this is quadrant 1. Quadrant 2 is the same point but negative positive. Quadrant 3 is the same point, but they're both negative. And quadrant 4 is the same point, but positive negative. So we're done with the first part. Okay. Now comes part 2. So for part 2, I'm going to cut the circle in 12 equal parts. Okay. Right. But remember that I told you that these will always be the same. You see, there they are. Even when they simplify, they will always simplify to the same radian, degrees, and point. Now here's going to divide the circle into 12 equal parts. So each quadrant, I'm going to cut it in 3. Okay. Now I'm going to do the radians first. So for the radians, I'm going to count by pi over 6. So every time I'm going to keep adding pi over 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, 7, 8, 9, 10, 11, 12. 12 pi over 6, right? Now these are the ones that can be reduced. You see how those can be reduced? But let's do them one at a time. Okay, 2 pi over 6 is gonna equal pi over 3. 3 pi over 6 will give us pi over 2. 4 pi over 6 will give us 2 pi over 3. And 6 pi over 6 will give us pi. 8 pi over 6 will give us 4 pi over 3. And 9 pi over 6 will give us 3 pi over 2. 10 pi over 6 will give us 5 pi over 3. And finally, 12 pi over 6 will give us 2 pi. So I'm done with the radians. Okay. Now comes the degrees. So for the degrees, we're going to count by 30. Okay, so we're going to start with 0 and then 30. And then we just keep adding 30 every single time. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. I'm done with the radians and degrees. Now comes the points. Remember the points, guys, these, the 0 or 2 pi will always be the same points. Pi over 2 will be 0, 0, 1. The pi will be negative 1, 0. And the 3 pi over 2 will give us 0, negative 1. Now, here comes the points. Okay, again, recall on the not the previous slide, but the other one where I said that everything with a 6 on the bottom of the denominator, this is going to be your point, right? The square root of 3 over 2, 1/2. But it depends on the quadrant, if it's going to be positive or negative, the x and the y. So in quadrant 2, we have the 5 pi over 6, but it's going to be negative positive. And quadrant 3 is 7 pi over 6. They're both going to be negative. So it'll be negative square root of 3 over 2, negative 1/2. And finally, in quadrant 4, we have 11 pi over 6, which is going to give us positive and a negative. Now, the other point, right, with a 3 in the denominator, is going to be the pi over 6, right? I mean, the same thing with the 6 in the denominator, but all you do is switch the x and the y. So this becomes 1/2 square root of 3 over 2, right? And so we have that in quadrant 2, which is negative positive. Quadrant 3 is down here in the 4 pi over 3. They're both going to be negative. And quadrant 4 will be the 5 pi over 3. It's going to be positive, negative. So those are my points, guys, right? So that's it for part 2. Now, the last thing we got to do is put them all together. Okay? Put part 1 and part 2 together. So this is part 2. Now, part 1 was the one that was a pi over 4. Remember? I mean, that's why I put it in pink. That was a pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And degrees was 45. So if we go 90 plus 45 will give us a 135. Or else you can do this, guys. What's between 120 and 150 is will be 135. What's between 210 and 240, right, is going to give us 225. And 7 pi over 4 will give us 315. Remember the point? The points were the x and the y were the same, right? The square root of 2 over 2, square root of 2 over 2. So, but quadrant 1, there was going to be positive, and quadrant 2 is going to be negative positive, and quadrant 3 it was going to be negative, and quadrant 4 is going to be positive negative. You see, guys, that's how you construct a circle. And I believe that if you apply, I mean, try to memorize it in 2 parts and then put it together, you'll be able to construct it. Okay. So again, it's good to know the inner circle, because some instructors will not let you use the inner circle or the handout on exams and stuff. So it's good to memorize it or to know it. Okay. That was number 1 on the exam review. Well, anyway, here's a summary on the constructing the circle, right? Here's a summary. For part 1, you divide the circle in 8 equal parts. Right? That's the summary. And then we're going to count. We start with 0, and we're going to go counterclockwise, and then we're going to count by pi over 4. And we'll keep adding pi over 4 until we come to 8 pi over 4. And then for the degrees, we start with 0, and then we keep adding 45 degrees until we come to 360. Every radian with 4 in the denominator has a point of square root of 2 over 2, square root of 2 over 2. And make sure the signs match the quadrants. Okay. Now part 2. Part 2, I'm going to divide the circle in 12 equal parts. Okay. And then I'm going to start at 0 and keep adding pi over 6 until I come to 12 pi over 6. And then we simplify. And then, right, we're going to start with the degrees. We start with 0, and we keep adding 30 degrees until we come to 360. And every radian with a 6 in the denominator has a point of square root of 3 over 2, 1/2. And every radian with a 3 in the denominator has a point of 1/2 square root of 3 over 2, but it depends on the quadrant. The signs depend on the quadrant. And then that's how you, summarize both parts 1 and 2, and then at the end you put them together. Okay, that was number 1 on your review. Number 2, you have to know how to convert degrees to radian. What they use here, guys, they use the equivalence of pi radian to 180 degrees. So that's how you convert it. Okay, let me show you what I mean by that. If they give you the degrees, right? If you want to go from degrees to radian, right? You're going to get the given degrees and multiply by pi radian over 180. This way the degrees will cancel. Okay. Example, convert 65 degrees to radian. So we're going to multiply 65 degrees times pi radian over 180. It's going to give us 65 pi radian over 180, right? The degrees cancel. So we're there with 65 over 180. Then we reduce it, and it becomes 13 pi over 36. That's your answer, guys. Number 3, convert 200 to radian. 200 degrees. Again, same process. We multiply 200 degrees times pi radian over 180. Right here, the 0 degrees and 0 degrees cancel, so I'm left with 20 pi over 18 radian. Now this can be reduced, right? You multiply both by 2. And you have 2 times 10 pi and 2 times 9, right? Which is equivalent to 20 pi over 18. The 2 becomes 1, so we have 10 pi over 9. That's the answer. Now, you also have to know how to convert radians to degrees. Okay. So for number 4, right, they give us pi over 5. You want to convert it to degrees. So you're going to multiply by 180 over pi radian. This way the pi's can cancel. See, the pi's will cancel. So 180 divided by 5 will give us 36 degrees. Number 5, convert pi over 12 to degrees. Again, you multiply by 180 degrees over pi radian. the degrees will cancel, the pi's will cancel. If you divide 180 divided by 12 will give us 15 degrees. That's your result. Okay, now, number 6. This is find the exact values of the 6 trigonometric functions of the angle theta. Hey guys, to find the 6 trig functions, we have to know also what the hypotenuse is. So the first thing, we're going to use a Pythagorean theorem to find the hypotenuse. So a squared plus b squared will give you c squared. C squared will always be the hypotenuse. It doesn't matter if this is a or b, right? But in this case, right, I call this a, I call this a, that's b, but in reality, guys, if this is angle a, this should be little a. But here, guys, I have it mixed up for now, but it doesn't matter for now. But later on, guys, if angle a, right, this is angle a, so across it, the length across it should be little a. But here, guys, I just left it like that. I made the 8a and that b. Okay. Anyway, a squared is 64. C squared is 36. So we add them, it's going to give us 100. Now to solve for c, we take the square root of both sides. So c equals 10. So now I got my hypotenuse. Okay, now, because this is considered the adjacent side. So the adjacent is going to be 8. The opposite is going to be 6. The hypotenuse is going to be 10. Okay. Now you also have to know the cosine, the sine. The cosine is adjacent over hypotenuse. The sine of theta is opposite over hypotenuse. And the tangent is opposite over adjacent. Okay, now the cosine and the secant are inverse of each other. So if the cosine is adjacent over hypotenuse, then my secant is hypotenuse over adjacent. And same thing goes with the sine. The sine and cosecant are also reciprocals of each other. So if the sine is opposite over hypotenuse, then the cosecant will be hypotenuse over opposite. And again, same thing with the tangent and cotangent. They're opposite reciprocals. So for the cotangent will be adjacent over opposite. So for the cosine, right, it's going to be adjacent, which would be 8 over 10. Then you have to simplify, which would be 4/5. And we found the cosine, well then we also find the secant because all we do is use a reciprocal, 5/4. The sine, right, is going to be opposite over hypotenuse will be 6/10, which will give us 3/5. And again, and we found the sine, we also find the cosecant because it's a reciprocal. So it'll be 5/3. The tangent is going to be opposite, which would be 6 over adjacent, it'll be 6/8. And we simplify it, it's going to give us 3/4. And the cotangent will just be the reciprocal of the tangent, which will give us 4/3. So those are my 6 trigonometric functions for that angle. Okay, now how do we apply it in real life? Okay, this is number 7. This is a guide wire. A guide wire runs from the ground to a cellular tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees. See figure. See, there's the sketch for that particular problem. Again, this is my tower, which is 150 feet. The angle that it makes is 43 degrees. So we're trying to find, it says here, the angle between, let's see here, how long is the wire? So we're looking for this wire here. So we're looking for the hypotenuse, right? And let's see, and then how far from the base of the tower is a wire anchored to the ground. So we're looking for this out here, guys. This is for part B. We're looking from the ground where it's anchored to the base of the tower. So we're looking for the adjacent. Okay, now, so you always have to think to yourself what's given and which trigonometric function can I use? Okay, so here we go. To find let's see here, to find the hypotenuse, right? They give us the angle and they give us the opposite. So I have to use something, to find the hypotenuse, I have to use something that has opposite and the angle, right? So we're going to use a sine because sine will be opposite over hypotenuse. So it's going to give us a sine of 43 degrees equals to 150 times the hypotenuse. Now here, guys, right, we can use proportions. So I'm going to switch the hypotenuse and the sine of 43 degrees, right? You can do that because that's legal, okay? That's legal by using the properties of proportions. So now the hypotenuse will be 150 over sine of 43 degrees, right? Put it into the calculator and make sure that your mode is in degrees, right? So it's going to give us something like 219.9 feet. So the wire is about 219.9 feet, or say about 220 feet. Now for part B. For part B, right, we're looking for the adjacent, right? So what do we use? We're going to use tangent because tangent is opposite over adjacent. Because here, guys, we cannot use the cosine. Why? Because the cosine doesn't give me the adjacent side, nor the hypotenuse. That's why there's two unknowns. That's why the cosine cannot be used. Okay? So the tangent will be opposite, which will be 150. The tangent of 43 degrees equals to 150 over adjacent. And again, here, guys, I'm going to use the properties of proportion. So I'm going to switch the adjacent with the tangent of 43 degrees. We're going to use a calculator. It's going to give us 160.9 feet. So that's how far the base of the tower is to the wire that's anchored to the ground. So from here, guys, from the wire that's anchored to the base of the tower is 160.9 feet. That's how you apply these type of problems like in real life. Okay, now the next thing is finding the arc length. Okay, the arc length is equal. A stands for arc length, R stands for radius, and theta stands for degrees, right? For the angle. But you have to convert it to radians, because most of the times it's given in degrees. You have to convert that to radians first. So it gave us number 8. A circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle of 240 degrees, as shown in figure below. Okay, so the first step, guys, we have to convert the angle, the degrees, into radians. Okay, so 240 degrees times pi radians over 180, right? The zeros cancel with a degree, so 24 over 18 will give us 4 pi over 3. So theta is 4 pi over 3, and the radius is 4. So plug everything in. It's going to give us 16 pi over 3, right? Use a calculator. And the result is approximately 16.76 inches. That's your answer, guys. Number 9, area of the sector. The area of the sector is equal to A, area equals to 1/2 R squared theta. And again, theta is measured in radians. Okay. Example number 9. A sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees as shown in the figure below. Okay. So you want to find out how much area was watered by the sprinklers, all this area here. Okay. So we can use a formula. So find the area of the fairway watered by the sprinkler. So again, right, the theta, the degrees, has to be converted to radians. So we use a formula from converting degrees to radian will give us 120 degrees times pi radian over 180. So we're going to give it 120 pi over 180, which simplifies to 2 pi over 3. So I got my theta and I have my degrees. My degrees, guys, I mean my radian is 70, right? Because that's my radians. I mean, that's my radius, not radians, my radius. So plug everything in. So 1/2 70 squared times 2 pi over 3 will give us 4,900 pi over 3. Right? Put it in the calculator. It should give us approximately 5,131 square feet. That's how much the area that was watered by the sprinkler. Okay, now this is number 10. It says, let the point -3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent. Okay. Okay, here, guys, what we need to do, we need to find R. Right? And also the quadrant which is at. This is quadrant 2. Right? which says that the sine is going to be positive, the cosine and the tangent are going to be negative. But how do we find r? Okay, r is equal to x squared, the square root of x squared plus y squared. So r is equal to, x equals to -3, y equals to 4. And now to find r, all we do is plug in the values for those particular variables. So it's going to give us the square root of 25, which r is equal to 5. So I find my r. Now sine is y over r. Cosine will be x over r. And tangent will be y over x. So sine is going to give us 4 over 5. Cosine will be -3 over 5. And tangent will be 4 over -3, which will be -4/3. You see, guys, my sine is positive, and cosine and tangent are negative. Okay. Now, let's move on to number 11. This one here, guys, is a little bit more challenging, and a lot of students have trouble with this type of problems, okay, because they give you the conditions. Okay, now, it says here, given the tangent of theta is equal to -5/4. And the cosine of theta is more than 0, which is positive. Find sine theta and secant theta. So here, guys, we have to know in what quadrant the first condition lies, which is a tangent of -5 over 4, and also the condition where cosine is positive. Okay. Now, hey guys, my tangent is going to be negative in quadrants 2 and quadrants 3, because the sine is a y over the x, right? So the tangent is negative where the sine and the cosine, or the x and the y, have different signs. You see, guys, in quadrant 1, everything's positive, so the tangent will be positive. In quadrant 2, the sine and the cosine are negative, so my tangent will be positive, right? Because they have the same sign, so the sine over the cosine, like negative over negative will give me a positive. So quadrants 2 and 4 meets the condition for this particular, for the sine to be negative. Now we repeat the process for the cosine. The cosine is positive in quadrant 1 and quadrant 4, right? So you take the intersection of both, right? So the answer will be in quadrant 4, which means everything that has a sine is going to be negative. Everything that has the tangent will also be negative. So, right, so since tangent is equal to y over x, means x is positive, right, because it's quadrant 4, and y is negative. Okay, now, guys, I need to find r. So r is equal to x squared plus y squared, so all we do is plug in the values for x and y. And r will be the square root of 41. That's my r. So the sine is going to be opposite. It's y over r, or opposite over hypotenuse, right? But here, guys, we use the y over r. So it's going to be -5 over the square root of 41, right? We have to rationalize the denominator. This will give us -5 square root of 41 over 41. And for the secant, right, we know that the secant and the cosine are opposite reciprocals. So if the cosine is x over r, then my secant will be r over x. So my r is square root of 41, and my x is 4. That's my solution, guys. So these are my answers. And I believe students struggle with these type of problems, guys, because they don't understand where tangent is negative and positive. I believe that's what the issue is. But hopefully, the way I explained it, will make a little bit of more sense. Okay, now we're doing the sketching, okay? I'm going to sketch 12, we're going to sketch something with a sine, and for 13, something with a cosine. So what do we need to do to sketch a sine wave? Okay, I want you to graph only one period, because two periods, guys, all you do is continue in the same motion. But if you do one period, you're able to sketch 2 or 3 periods, okay? Okay, now, for here, guys, we need to know what the A is. The A is 3, which is the amplitude, which means it's going to go up 3 and down 3. And we have to know what the B is. The B here, guys, is the same thing as 2, right? My B is 2. The B is crucial to find the period, because the period is 2 pi over B. right? So 2 pi over b will be 2 pi over 2 will give us pi. Now I need to find the other key points, right? Which are 5 key points, right? We always start with 0. So we're going to be, right? So for that, guys, for the other key points, we're going to divide the period divided by 4. That's how you find the other key points. So the period is pi, so we're going to be pi over 4, which means when you sketch, when you draw the coordinate plane, you start with pi over 4 and you keep adding pi over 4 because every single point, every single unit there is pi over 4. That's how long it is. With 0, and then it'll be pi over 4, and then 2 pi over 4, 3 pi over 4, and 4 pi over 4. And guys, if you notice, the period is pi, right? So the last point has to give you the period, which is pi, which is correct. But now, guys, let's go back and simplify. The 0 cannot be simplified. No, the pi over 4. 2 pi over 4 will give us pi over 2. 3 pi over 4 stays how it is. And 4 pi over 4 will give us pi. And again, the period must match the last point there, which is correct, right? We know it's right. Okay, now. So as I did the PowerPoint last week, I believe the first week was on week 2 was on graphing, right? We know that the sign starts at 0, right? But this is my amplitude, which is 3 and negative 3. The first one will be 0, 0 because the sign always starts at 0. This is going to be pi over 4, 3. There's a point up there. And then it'll be pi over 2, 0. And the next one will be 3 pi over 4, negative 3. And finally, pi, 0. So those are my points. Guys, but most of the times, they want you to graph 2 periods. If you graph 2 periods, guys, it's going to come down here. It's going to go down like that in the same motion. Okay? Okay, now, let's go to number 13. Number 13 is going to be one that has horizontal translation. Okay? Which means y equals to a sine of bx minus c, or y equals to a cosine of bx minus c. For the sine and cosine, we do the very same process to find the points. Okay, but with this translation, okay, I like to apply it at the very end. Okay, let me show you what I'm talking about. Okay, so here, guys, my a, right? So my a is going to be 1. My b is 4, right? Because the b is for the x is going to be 4. So the period will be 2 pi over b, so it will be 2 pi over 4. Which reduces to pi over 2. So again, we're going to start with 0. I'm sorry about that. The period is going to be period over 4, which would be pi over 2 over 4, which will give us pi over 8. And again, we start with 0, then pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Okay, that one stays the same. The pi over 8 cannot be reduced. 2 pi over 8 will give us pi over 4. 3 pi over 8 stays how it is. And 4 pi over 8 will give us pi over 2. And again, guys, remember, the period, which is pi over 2, must always match the last point here, which is pi over 2. So I know it's correct. Okay, now. So the key points will be 0, 1, right? Because it's going to be 0 amplitude. And then pi over 8, 0. And then because the cosine starts at the amplitude. And then it's going to give us where we at, pi over 4, negative 1, then 3 pi over 8, 0. And then pi over 2, 1. You see, guys, here's a pattern, guys, for the cosine, right? But this is for the regular cosine, right? Like the parent graph, it's going to be you start at 0, 0. And then pi over 2. Oh, no, guys, this is for the sine, guys, but this is a cosine here. Okay, I did a mistake here. This is supposed to be 0 amplitude, pi over 2, 0, pi negative amplitude, and 3 pi over 2, 0, and 2 pi amplitude. Okay, so this is for the sine. It's supposed to be, but this is the cosine, the graphing. So I did a mistake there, guys. Okay. Okay, now, guys, now let's apply the horizontal translation. Okay, remember that the left endpoint will be 4x minus pi. Will be bx minus c, right, equals 0. So we let 4x minus pi equals 0, and 4x minus pi equals 2 pi. So if we work it out, it's going to give us pi over 4 and 3 pi over 4. Okay, so if you notice, every single x value has to move to the right pi over 4 units, because this is my left endpoint. Okay, so I'm going to add pi over 4 to every x value, which will give us pi over 4, 1. That'll be my first point, because it shifted pi over 4 units to the right. Then it's going to be pi over 4 plus pi over 8 will give us 3 pi over 8. And then pi over 4 plus pi over 4, right, will give us pi over 2, negative 1. And then 3 pi over 8 plus pi over 4 will give us 5 pi over 8, 0. And then finally, right, pi over 2 plus pi over 4 will give us the 3 pi over 4. If you notice, guys, you see this is my left endpoint, which is correct. And this is my father's right endpoint, which is 3 pi over 4. Now, guys, right now, all we do is, right, it's going to be the shift, right? So this is going to be because it's supposed to be here, guys. But it shift to the right, the units there. Okay. You see, because it starts here, guys, the cosine starts at the amplitude, right? So it just moved pi 4 units to the right. So those are all the pi over 4, 3 pi over 4, pi over 2, and 5 pi over 8, and finally 3 pi over 4. So that's my first point, the pi over 4, 1, which is here. And then 3 pi over 8, 0. And then pi over 2, negative 1. And then 5 pi over 8, 0. And finally, 3 pi over 4, 1. You see the graph shifted pi over 4 units to the right. So the graph, guys, is from here to here. Okay, that's how you graph the translation of a sine or a cosine. Number 14. Find the exact values of the expression tangent of arc cosine of 2/3. Hey, guys, what's in the inside, the arc cosine of 2/3, guys, is where you're going to get, is where you're going to form your triangle. All right, so I know this is quadrant 1, because the arc cosine has the range from 0 to pi. So I know this is quadrant 1, which means the sine is going to be positive, cosine, everything's going to be positive. So again, from the arc cosine of 2/3, we're going to form our triangle. Right? So here's a triangle. So the adjacent will be what, 2? Hypotenuse will be 3. So I need to find for the opposite. So a squared plus b squared equals c squared. So we have 2 squared plus b squared equals 3 squared. Right? So b squared equals to 5. So b equals to square root of 5. Now I find my tangent. The tangent is opposite over adjacent. So it's going to be the square root of 5 over 2. That's my tangent, guys. That's what we're looking for. Now let's try another one. Because after a while, when you start getting like something like not a number, something numbers mixed with a variable, students begin to get confused. Hey guys, but just apply the same concept and you should be okay. So again, right, the arc cosine will be positive in quadrant 1. So from the arc cosine of x over 3, right, we're going to get our triangle, right? So the x is going to be adjacent, and the hypotenuse will be 3. So again, as before, we're looking for the opposite. So it's going to be x squared plus b squared equals 3 squared. So b squared equals to 9 minus x squared. So b equals to the square root of 9 minus x squared. So I got my b, which is the opposite. Now again, we're looking for tangent. So tangent is going to be opposite over adjacent. So the opposite will be 9 and the square root of 9 minus x squared. And the adjacent will just be x. So that's my answer, guys. Okay. Number 16. It says a boat is pulled by means of a winch located on the dock 5 feet above the deck of the boat. See the figure, right? So this is a winch, and this is 5 feet above the. It says 5 feet above the deck. So let theta be the angle of elevation from the boat to the winch, right? So this is the angle of elevation right here, and let S be the length of the rope. That's my S, the length of the rope. So first, they want you to write theta as a function of S. Okay, so with a given, guys, I'm going to form my triangle, right? This is my 5, this is my theta, and that's the length of the rope, my S. So we have opposite, right, over hypotenuse. So we can use a sine, right, because it gives us opposite over hypotenuse. So it's going to be the sine of 5 over S. But they want you to write theta as a function of S, right? So I have to get rid of the sine. How do we do that? We take the arcsine on both sides. So theta equals to the arcsine or the inverse sine of 5 over S. Okay, that's the answer for A part. Now for B part, it says when S is 40 feet, right, when the length is 40 feet, right, find theta. So theta is equal to the arcsine of 5 over 40. Use your calculator. It's going to give us 7.13 radians. It's up to, in the homework, it wanted 13 radian, in radian. But this will give it in degrees and radian. That way, however the instructor wants it, you'll be able to find it. Again, if you use the calculator, guys, make sure that the mode is in degrees, right, to get degrees, and make sure that, and then switch it to radian to find it in radian. Then when it's 20, well, it'll be the same thing. We just plug in 20 where the S is. It'll be 14.47 degrees or 0.25 radians. Okay, that covers number 16. Number 17, they want you to solve the triangle. Okay. They give us to that triangle, you have to find because if you notice, the capital letters is the angle, and the smaller and the lowercase letters are the sides. So we have to find big A, big A, big B, big C, little a, little b, little c. In other words, so angle A is 34.2 was given. B is 19.4. And we should know that C is 90 degrees because that's a right triangle, right? So we have to find B, little a, and little c. So let's start out by finding angle B. Right? We know that all the angles, when you add them up, has to give you 180 for a triangle. So right, to solve for B, it'll be B equals to 180 minus A minus C. So let's plug in the 34.2 for A and the 90 degrees for C. So B equals to approximately 86.8 degrees. I got my B. Okay, now we have the angle, right? We have the angle and we have adjacent. That's given. So we need to use a function, a trig function that has adjacent. So we can use cosine, we can use tangent, but not the sine, because the sine is opposite, right? So we're going to use for little a, it's going to be opposite over adjacent, which will be the tangent. Right, we multiply both sides by 19.4. So it's going to give us 19.4 times tangent at 34.2 will give us little a. Make sure that your mode is in degrees. So it will be approximately 13.2. I got my A. Now to find your B, to find the C, guys, you can use the Pythagorean theorem to find C, or we can use, let's see, they give us adjacent over hypotenuse, so we can use a cosine. Right? So it'll be cosine of 34.2 degrees equals to 19.4 over C. Because remember, guys, by using the proportions, we can switch the C and the cosine of 34.2. We use the calculator, and C equals to 23.5. That's my value for little c. So that's how you solve
Good brother
I mean a right triangle. Okay, that's how you solve a right triangle. Okay, now let's go to number 18. Let's do another one. Because but here, guys, they didn't give us an angle. We only have angle C. How can we do this one here? Okay, we know that angle C is going to be 90, right? Well, A is 3, the little b is 4, and C is 90 degrees. So now, what can we use, right? So to find little c, we can use a Pythagorean theorem. So 3 squared plus 4 squared equals c squared. 25 equals c squared, so c equals 5. Now, you see, now we have the c. Now I can use anything that I want. Anything at all. I can use the cosine, the sine, or the tangent. Okay? Because they give us all the sides. So here, guys, I decided to use the sine. Because to find angle A, I need to use a sine, because the sine of angle A is going to be opposite, or hypotenuse will be 3 over 5. Right? So to get rid of the sine, I take the arcsine of both sides. So A equals to the arcsine of 3 over 5. Put it in the calculator, and you get something like 36.87. That's angle A, 36.87 degrees. Now to solve for B, guys, right, we can use that A squared plus B squared, that A plus B plus C must equal to 180, right? Because all these angles must equal to 180. So B equals to 180 minus A minus C. So I got my A is 36.87. I got my C. So B equals to 53.13 degrees. That's my B. Also, guys, one more thing that I want to say here, guys. If you wanted to, I could have used to find angle B, I could have used something like any one of these. For example, for the cosine, it would have been adjacent 3 over 5 to find angle B. Or I could have used the sine. The sine will be 4 over 5 because it's opposite over hypotenuse. Or I could even use the tangent. The tangent of angle B will be opposite over adjacent 4 over 3. You see, guys, so you can use anything at your disposal. But here, guys, I decided to use all the three angles must equal to 180 because that's what I've been using. But here, guys, you can use anything that you want. Number 19. This is a ladder that is 20 feet long, leans against the side of a house. The angle of elevation of the ladder is 80 degrees. Find the height from the top of the ladder to the ground. Okay, so let's draw a little picture here. Okay, let's say this is the side of the house. Okay, and this is my 20-foot ladder, and this is from the ground from the house, right, to the bottom of the ladder. Let's put everything that's given. The ladder is 20 feet. The angle of elevation this is 80 degrees, and we're looking. It says find out the height at the top of that. So we're looking for this part here. Right, we're looking for x from the height to the top of the ladder to the ground. So what do we use? Okay, we have to use something that has opposite. We cannot use cosine. We cannot use tangent. Why? Because tangent gives you adjacent, right? Tangent will give you opposite over adjacent, and the adjacent is not given. So we're forced to use the sine, which will be opposite or hypotenuse. So the sine of 80 degrees is equal to x over 20. Multiply both sides by 20. So x equals to 20 times sine of 80 degrees. So x is approximately 19.696 feet. That's the answer that we're looking for. So it's going to be, say, about 20 feet approximately, guys. This is the answer for number 19. Now, number 20. Says the sun is 25 degrees above the horizon. Find the length of a shadow cast by a building that is 100 feet tall. Okay. So again, there's a sun. It's about 25 degrees, right? This is the building is 100 feet tall. So you're looking for the shadow, right? So the shadow is this part here. That's what we're looking for. So again, what's given? The angle and the opposite. Right, but we're looking for the adjacent. So we have to use something that has opposite or adjacent. Right? we are given an angle, looking for adjacent. So it's got to be the tangent, because tangent is opposite or adjacent. So we have to use tangent. So tangent at 25 degrees equals to 100 over x. Again, we can use the proportion rules, or the properties of proportions. So we switch the x and the tangent at 25 degrees. So it's going to be about 214.45 feet. That's the length of the shadow. Okay. Number 21, I think this is the last one, guys. Okay. It says here, an observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angles of depreciation to the ships are 4 degrees and 6.5 degrees. See figure below. So guys, so here's the plan, guys, okay? This is 350 here, right? So I'm gonna find form two triangles, right? The first triangle will be, let's call this ship 1 and ship 2, right? So the first triangle, right, is gonna be this one here, which will be this whole thing right here, right? This whole thing, guys, is 6.5 degrees. So let me take this triangle and, right? This is 350, because if this is 350, there has to be 350 also. And this will be 6.5 degrees. So we're looking for this, right? We're looking for the distance here, guys, right? This distance here is the same thing as this distance up here. So we're looking for distance 1. Let's call it D1 for distance 1. So what's given from this triangle, right? What's given is the opposite, and we're looking for the adjacent, so we have to use a tangent. But okay, and this would be my second distance, ship 2, right? So it's going to be this triangle here, right? It's going to be from here, but it's going to be the one that has 4 degrees. So this is again 350. This is 4 degrees, and we call it distance 2. Okay, so after we find both of them, right? So we're looking for this distance here. We're looking at distance, how far are they apart? So that's what we're looking for. Okay. So what are we going to use? We use tangent, because what's given is opposite of the angle, and we're looking for the adjacent, right? For both of these. So tangent of 6.5 equals to 350 over D1, right? We can use the properties of proportions. So we're going to switch the distance 1 and the tangent of 6.5. Use the calculator. And so D1 is 3,071.91 feet. So this is 3,071.91 feet. Now, let's repeat the process for distance 2. So distance 2 is equal to 350 over tangent of 4 degrees. So from here to here, guys, it's 5,005.23 feet. Right, so to find D3, right, the distance that we're looking for, how far they're apart, let's call it D3. So D3 equals to D2 minus D1. That's my D3, distance 3. So it's going to be 5,005.23 feet minus 3,071.91 feet. So it's going to give us something like 1,133.3 feet. That's how far the two ships are apart. Okay. Because I hope this exam review was helpful. And if you have any questions, please let me know. But let's go back to the host. That way they can tell you more things about what's coming up in future events.
Thank you, Mr. Istasi, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on a YouTube playlist. Today's session will also be available on that playlist later on today. Also linked is our short survey to help us improve our TVE sessions, so please take time to fill that survey out, please. Before you leave, I do want to share the TVE sessions that we will have next week. We'll be back with Happy Math Hour next week, which 1332 Math. We'll be covering conditional and related statements, symbolic arguments, and the Euler diagrams. Math 2412 will be covering verifying trigonometric identities and implementing trigonometric formulas. And today at 1, we will have the student success topic, which will be an overview of the student support services here on the programs at EPCC. Thank you all for coming in. Good luck with your first exam, guys. We hope that you all have a lovely weekend. If you have any questions, like Mr. Isasi said, use your chat or feel free to open up your mic.